Hello everyone, I welcome you to my YouTube channel. In the last few months, we have been looking at petrophysical analysis of well log data using Excel and Techlog Software. And in the last video, I showed you how to create petrophysical analysis project on Techlog Software. I also showed you around Techlog user interface. And then we imported log data. At the end of that video, I said this will be my last video on petrophysical analysis of well log data. But then I think it is better I show you how to carry out some calculations on Techlog Software. So in this video, I'm going to show you how to calculate volume of shales. But you have to bear it in mind that before you start calculating volume of shales, these are the things you need to know. After import data, you need to do data QC or data adjustment. You know that during data QC, there may be a need for data adjustment. And after data adjustment, you need to create zonation and depth references. So after depth references, you can then start volume of shale calculation. If you go to my Udemy course, you will see all these things there. Okay? Now, shall we begin to look at volume of shale calculation? There are two methods of calculating volume of shales, and I'm going to walk you through the first method. However, you can find the second method in my Udemy course. So to start with first method, let's go to Petrophysics and then click on this icon. Now, we are going to use gamma ray log to carry out this exercise. However, you can use neutron density, sonic density, neutron sonic, as well as resistivity log to calculate volume of shale, depending on which of these data is available and what you intend to achieve, because you might overestimate the volume of shales due to the presence of odd sands or feldspathic sands that is masking the actual volume of shale. Now, this is what I mean. If you have a feldspathic sand body or odd sands and you decide to use gamma ray log to estimate the volume of shales, the gamma ray log will overestimate the volume of shales because on gamma ray log, the feldspathic sands or odd sands will appear as normal sands. But of course, it is not normal sands. It is feldspathic sands or odd sands. And you may want to ask, what are feldspathic sands? Well, feldspathic sands are sands that contain high amount of radioactive element, such as feldspar, uranium, and so on and so forth. So in this kind of situation, the best logs to use in order to have reasonable volume of shale is neutron density logs. And you may want to also ask, how will you know if you have overestimated your volume of shales? Well, if you calculate volume of shales using this manual formula and you compare the result with this dirty sand body, your results should also reflect the presence of shales in this dirty sand body. And to explain further, if you have a clean sand body, the volume of shales should be low compared with having a dirty sand body. So when you have a dirty sand body, the volume of shales should be high. So go to shale volume. So for the purpose of this study, we are going to use gamma ray to calculate the volume of shales. So click on this. Now we have gamma ray in place. So let's click on create. So you have workflow manager dialog box here. So for input, bring in your data. So go to X1 well. And then drag in your data. Okay. And then for X2 well, drag in your data as well. All right. And then let's go to zonation. And then let's go to our tops, that is our zonation. And then click the tops. And then click on this arrow. All right. Now, what we have done is we have transferred our sand tops to Workflow Manager under zonation. And then let's go to parameters. Now, if you look at under these parameters, you will see GR matrix and GR shell. Now, this is what we are going to work with. The values you are seeing here are default values. Okay, so we are going to come up with gamma ray matrix and gamma ray shell for SAN2 top in X1 and SAN2 top in X2. So let's go to plot and then histogram. All right, a dialog box like this will pop up. And then let's go to project browser. Let's go to X1 to bring in our GR. Click and drag and drop here. All right, so this is what we have. And let's go to zonation. Zonation. And then click on the sand we are working with. And then click the shell above and the shell below. All right. And then let's scroll down to see what we have. So we're going to record this minimum value and maximum value for gamma ray matrix and gamma ray shell respectively. So now for minimum value, we have 24.2. Okay, so let's record that under X1 SAN2 top. 24.2. 24.2. And for gamma ray shell, the maximum value is 85.18. 85.18. 85.18. All right. Let's go back and then let's do for X2. Let's delete 1xgr. Press delete key. All right. Project browser. Bring in X2gr. X2gr. Click and drag and drop here. And then go back to zonation to ensure the sand is active, and then the shell above and shell below is also active. Okay. Now this is the value of minimum value and this is the value for maximum value. So we have 17.25. We're going to round it up to 2 decimal places. So we have 17.25. So this is SAN2 top for X2L. 17.25. All right. And for maximum value, that is 80.78. 80.78. 80.78. All right. So let's go back to the histogram and then close the histogram. Save histogram, say no. All right. Now at this stage, come to this drawdown, click save. And then before we click on this icon, let's go to project browser so that by the time we click on this icon, we'll see the volume of shell GR here. So click on it to see what we have. All right. So as you can see, we have volume of shell derived from GR. So now we have calculated the volume of shells. If you go to X1, because this is X2, if you go to X1, you will see the same volume of shell there. All right. So this is for X1 well. All right. So this is how to calculate the volume of shells for the first method. And this is where I'm wrapping up this video. Please like, leave a comment, share, and subscribe. so that you will be notified whenever I upload a new video. So thank you and goodbye for now.